Hello friends, welcome to Civil AG Academy. In this video, we are going to discuss about some more numericals of boat and stream chapter of quantitative aptitude. Okay, so let's start. So in this video, we are going to discuss about the numericals of boat and streams, okay, of part 3 video. If you have not seen part 1 and part 2, so go to the playlist and see the part 1 and part 2 video. Okay, so let's start the video. So the question is, you can see here, the question is, a boat while downstream in a river, okay, covered a distance of 50 miles at an average speed of 60 miles per hour. While returning, because of the water resistance, it took 1 hour, okay, 15 minutes to cover the same distance. What was the average speed during the whole journey? So you have to write whatever they have given here. Okay, so a boat while while traveling a downstream in a river covered a distance of 50 miles. So what I'm doing is I'm tabling here. You can see here I'm tabling here. Okay, I'm using the STD one. So this is speed, time and distance. Speed, time and distance. So I'm making the table here, two tables. So one for the upstream side and another one for the downstream side. This is the upstream side and this is the downstream side. So on the upstream side, always u minus v will be there, u plus v will be there. What is u plus v? What is u? U is the speed of the boat in the still water. V is the, what is v? V is the speed of the current. Therefore, the relative speed of the boat in the upstream and downstream is nothing but u minus v, and this is u plus v. A boat while traveling the downstream in a river covered a distance of 50 miles. So now it has covered a distance of 50 miles. Okay, so for downstream, okay, this is for the downstream. They have mentioned downstream. Okay, at an average speed of 60 miles per hour. The speed is given while traveling the downstream. The speed is given 60 miles per hour. While returning, because of the water resistance, okay, so when they return, the distance covered will be the same. Okay, and because of the water resistance, it took 1 hour 15 minutes. 1 hour 15 minutes means 1.25 hours. I am simply taking 1.25 hour. Okay, so 1.25 hour to cover the same distance. What was the average speed during the whole journey? So they are telling that what is the average speed. Okay, so first we need to find out this one. What is the speed? What is the speed of the boat in the upstream side? So we can easily find this one. There is nothing more logic here, because we know that in this table, if you see that speed is equal to distance by time, so which is equal to distance is 50 divided by 1.25. So this is 50 is in mile. Okay, so this is in hour, no need to worry. So you take multiply it on 100 on both sides, then it will become 50,000 divided by 125. So 125. Okay, so which is equal to, so 5 2s are 10, 5 2s are 10, 5 5s are 25. Okay, so this is 5 10s are 50, and so here 25 4s are 100. So therefore it comes to be 40. So 40 miles per hour. This is 40 miles per hour. So therefore the one which we have find out is 40 miles per hour. So this is 40 miles per hour. Since the distance is constant on either side, Okay, so he's moving from here upstream to downstream, the distance is 50. Again he's moving from downstream to upstream, then also the distance is constant. So when the distance is constant, we can use the formula. Okay, so if I call this is the upstream velocity, this is the downstream velocity. When distance is common, we have the formula 2ab whole divided by a plus b. What is a and b here? A and b is nothing but the speed. Okay, when the distance is common, then we can a and b are the individual speed. I call this is the a, I call this is the speed. This is the speed in the upstream side, this is the speed in the downstream side. So then it will be 2 into 40 into 60. So 2 into 40 into 60 divided by 40 plus 60. 40 plus 60. So we know that. So this will become, okay, so 4800 divided by, so 60 plus 40 is 100. So two zeros will cancel, and finally how much we'll get? So we'll get 48 miles per hour. 48 miles per hour. Therefore the distance is 48 miles per hour. The average speed, not distance, the average speed of both upstream and downstream side will be equal to, so 48 miles per hour is the answer for this question. Next question. Yes. So next question. A man can row 4.5 kilometer per hour in a still water. So in the sense they have given, okay, so speed of the person who is rowing, okay, so in a still water is simply 4.5 kilometer per hour. This is what they have given. Okay, if it takes 2 times, okay, as long to row the distance upstream, okay, so as to row the same distance in the downstream, then the speed of the stream is, they are simply asking what is the speed of the stream. So we need to table the things here for the simplification. So what I'm tabling here every data here, okay, of upstream side as well as the downstream side. Okay, so this is upstream side, okay, this is downstream side, usual notation. Okay, so this is speed, okay, so time, and as well as this is the distance. You know that the speed will be equal to, okay, always we write upstream side u minus v, and speed in the downstream side will be u plus v. Of course we know that this is a common notation that we need to follow. Okay, yes, then, okay, they have mentioned here, see that, okay, so a man can, they have given you, okay, they have given you. So what they have given here, so they have given you, see here, so u is how much? They have given 9/2. I am taking it as a 9/2. 4 to the 8 plus 1, 9/2. Is it not? U is equal to 9/2 minus v. In this case, 9/2 plus v will be there. Plus v will be there. Okay. And time. They are telling that, okay, if it takes 2 times as long, okay, as to row the distance upstream as the row in the same distance in the downstream. Distance is constant. Okay, if you make the distance is constant, downstream if it takes the time t, then upstream they have mentioned 2 times long, that is he will take 2t. What he is asking? So he is asking simply the speed of the stream, that is he is asking what is v. What is, so we know that from the both cases, upstream side distance will be equal to, okay, so distance will be equal to downstream side. Okay, so downstream side distance from the table only, we can see that, one distance is constant. So what is distance? Speed into time is equal to distance. So therefore I can write that speed into time, that is during the upstream, okay, in the upstream condition, the upstream side will be equal to speed into time, okay, in the downstream, because what they have mentioned, speed is constant. So what is the speed here? Okay, so what is the speed here? So speed is nothing but 9/2 minus v into time. So what is the time here? This is 2t. 2t should be equal to, so 9/2 plus v, 9/2 plus v into t. Okay, so TT will get cancelled. TT will get cancelled. So you can see here that 2 get cancels also. So we'll get 9 minus 2V will be equal to, simply 9 by 2 is 4.5. Okay, so 4.5 plus V. Okay, so if you take V here, then it will become 3V. If you take here 9 minus 4.5 is 4.5. Okay, so therefore, so what is V here? V is equal to 4.5 divided by 3. Okay, so 3 ones are 3, 3 15s are 3 5s are 15. So therefore, the speed of the current or the river water will be, so simply 1.5, okay, kilometer per hour. So therefore, the answer is, this is the answer, that is 1.5 kilometer per hour. So B is the correct answer for this question. Yes, so B is the correct answer for this. Okay, so next we are moving with next problem. Yes. So next problem, question number 14, we are going to solve here. Okay. See, a man takes twice as long to row a distance against the stream as to row the same distance in favor of the stream. So whenever there is a long, it means that it is telling about the time. It is telling about the time. Okay. The ratio of the speed of the boat in the still water to that of a stream. They are asking U by V, because U is the ratio of the boat in the still water. V is the speed of the stream. They are simply asking this. They have given only this much. Okay, they have given only this much. So simply you table the things. Okay, tabling easy you to picturize this problem. Okay, so that's why we are making the table, not more than that one. So picturization is, to getting the picturization, we are doing this tabling. Okay, so you know that this is TD, speed, time, as well as the distance, and you know this is upstream side. Always we write this is the downstream side. So upstream side velocity, the relative velocity will be u minus v always, and downstream side the velocity is equal to u plus v. Always we use this. Of course, yes. Speed, of course, they have not mentioned. I just take the same speed here because it is unknown here. Speed is u minus v, so this is also u plus. Okay, speed is same, unless otherwise they have given u and v. You substitute that one, otherwise you take the randomly that much only, that is speed. Okay, time they have mentioned. Okay, so if it is moving in the downstream side, it takes the time t. Then for the upstream side, it will take the 2 times of the t. They have mentioned the long, twice the long. Against means in the upstream side. On upstream side, if it takes 2 times, okay, the time which is taken by the downstream side. If the downstream, okay, downstream side, the time taken by the boat will be t, then upstream side it will take 2 times. Therefore, it will be 2t. And also distance is constant. They have mentioned the same distance. Of course, distance is constant. So what they are asking you, they are asking you to find out u divided by v. This is what they are asking you to find out. Okay. So what I will do is, I know that distance is constant. And what is the distance? Distance is equal to speed into time. So therefore, I will make that speed into time on the upstream side will be equal to speed into time on the downstream side. Okay, which is nothing but distance. Distance is constant because they are same distance it is covering. So therefore, so this will become u minus v into time. So time is 2t will be equal to u plus v multiplied by the time t. So you know that tt will get cancelled. So you'll get 2u, okay, minus 2v will be equal to, so u plus v. Okay, so u plus v. Okay, so if you take, you will become u is equal to 3v. Okay, this will u is equal to 3v. Therefore, u by v will be equal to 3:1. So therefore, the answer is 3:1. Therefore, the answer is 3:1. Okay, so therefore the answer is 3:1. Okay, so this is the solution of this problem. We are moving to next problem. Okay, so question number 13. We are moving here. Next problem. Okay, so first I will table things. You know that. Okay. So this is okay. So this is STD. This is upstream side. This is downstream side. Okay. So this is U minus V always. This is always U plus. This is always U plus V. Okay. Yes. Now see here, the speed of the boat in the standing water means he has given U is 9 kmph. Okay. And speed of the stream means V. V they have given 1.5. The problem they have given V is how much? So 1.5 kilometer per hour. So then what is this upstream side speed? Upstream side speed is equal to U minus V. What is U? U is 9. So V is 1.5. So 9 minus 1.5 directly we can write it 7. Similarly on the downstream side U plus V. U plus V is 9 plus 1.5. So I am writing it as a 10.5. Okay, so 10.5. Okay, so a man rose. Okay, a man rose to a place at a distance of 105 kilometer. Okay, so he's moving to a distance of 105 kilometer. Okay, and comes back to the starting point. Okay, so he comes back means, suppose if you take this is the upstream side, this is the downstream side. Okay, so person what is moving? So the person, okay, he goes and comes 2 times he will do, and on each time he is moving 105 kilometers. So that's why I'm writing 105 and as well as 105 kilometers. So then what is the total time taken by him in order to do so? Means what is the time taken from upstream to downstream if he is moving for a distance of 105, and similarly from downstream, okay, from here to here time, and as well as from here to here this time, the total time they are asking, that is the total time will be equal to simply T1 plus T2. You know that. Okay, so what is this T1? So T1 is the time taken. Is it not? So that's why I'm making here this is T1 and T2. Okay, so T1 and T2 is the total time taken. Okay, T1 and T2 is the total time taken. So simply if you take this is T1 and T2, you know that what is the time? Time is equal to distance by speed. So therefore from first case it will be 105 divided by 7.5. Okay, so 7.5. And similarly if you do the second case, if you come with the second case, the second case also, okay, so 105, that is the distance divided by time, that is 10.5. Okay, so 10.5. So from here you can see that this is the 10 hours. Okay, so 10 hours. And what is this? Just simplification you need to do. Okay, simplification you need to do. I will divide it by 15. So 15 5s, this will become 0.5. Okay, this will become 15 7s. 15 7s. Okay, so you know that. Okay, so you know that 7 whole divided by 0.5. So what I can write? I can write it 7 whole divided by 0.5 is 1 by 2. So therefore it comes to be 14. Is it not? So this is 14. So 14 hour plus 10 hour is equal to 24 hours. So therefore the answer is option D. So that is 24 hours. The time taken in order to go upstream as well as the downstream side or go and come back, you will take the total time, that is 24 hours. Okay, so this is the solution of this problem. Next we are moving with next problem. So next problem, so we are moving with, so the question number is 11. So question number 11 is the for that. Okay, see here, a boatman, before that one I will make your table here. So this is upstream side, this is downstream side. Upstream side is always speed is U minus V. This is U plus V. Okay, this is S T D S T. Okay, a boatsman goes 2 kilometers against the current. Against the current in the sense is moving to upstream side. Okay, upstream side is moving to the upstream side. Okay, upstream side means the relative speed is given. In the upstream side, the speed will be u minus v, simply as given that as a okay 2 kilometer against the current of the speed in 1 hour. So in the sense, they have given the speed, that is u minus v is equal to simply 2 kilometer per hour they have given. So therefore u minus v will be 2 kilometer per hour and goes 1 kilometer, okay, along the current in 10 minutes. So means they have given u plus v downstream speed, okay, so is equal to, so 1 kilometer divided by 10 minutes, okay, 10 minutes they have given, 10 minutes they have given. So we know that, so that is, okay, so 1 hour is equal to 60 minutes, 60 minutes. This means that 1 minute is equal to 1 by 60 hours, 1 by 60 hours. So we know this one, we are using that one. So which is equal to 1 kilometer divided by 10 into, you know that 1 minute means how much, 1 by 60 hours. So you take it 1 by 60 hours. So 6600 will cancel, you will simply get 6 hours. Okay, so therefore u plus v is equal to 6 hours. Therefore u plus v is equal to 6 hours. Then what they are asking, how long will it take to go 5 kilometer in the stationary water, means time in the stationary. Okay, I am taking it, see here, stationary water. So in the stationary water, what will be the speed? Speed will be the speed will be simply u, because u is the speed of the boat. Speed of the boat in the still water. In the stationary water, speed is equal to u. You know that speed is equal to distance divided by time. What they are asking you to find out, okay, how long will it take, means time. They are asking you to find time. So time is equal to d by u. Okay, so first we have not know about u, because u minus v, u plus v, we know that one. First we need to find that one. So first we need to find that one. And other than that, okay, so other than that, I'm using this here. Okay, so I'm writing here. So we know that u minus v is equal to 2, and also we know that u plus v is equal to 6. Okay, when you add, these two will get cancelled. So 2u is equal to 8, u is equal to, okay, so that is 4 kilometer per hour. So 4 kilometer per hour is the u. If u is 4 kilometer per hour, then v will be equal to 4 plus 2 should be, okay, 6. So that is, so 2 kilometer per hour. So we got that u and v. So we got that u and v. How long will it take to go 5 kilometer? So he has given the distance here. So therefore we know that solution t is equal to distance. Distance means for 5 kilometer. So I'm writing it, this is a 5 kilometer, because d is the distance, and u we have find out, u is the 4 hour. So that is 5 by 4 hour. Okay, so 5 by 4 hour. So 5 by 4 hour means 1 point, okay, so 1.25 kilometer per hour. Sorry, 1.25. Sorry, this is u is in terms, sorry, one minute. So this is 4 hour, not this is 4 kilometer per hour. 4 kilometer per hour. Okay, so therefore kilometer will get, you will get, so 1.25 hour. So 1.25 hour is nothing but 1 hour 15 minutes. Okay, 1 hour 15 minutes, because, okay, so 1 by 4 hour is nothing but 15 minutes. So therefore the time taken in the in the stationary water, okay, for moving a distance of 5 kilometers, okay, will be equal to, so 1 hour 15 minutes. This is a solution for this problem. Okay, next question. The next question. So this is a question number 10 we are solving now. Okay. A boat covers a certain distance in the downstream. So I'm writing here, see, I'm tabling here. So this is the upstream side, this is the downstream side. Okay, so we are using always u minus v, that is the speed. This is STD, speed, time, and distance. Okay, this is always u plus v. You know this one. Okay, so now I need to drag this input into the table. So what they have given, see here, a boat covers a certain distance in the downstream in 1 hour. Okay, in 1 hour. So the time taken, certain distance, I don't know, I will take it as a d. Okay, so for the moving that distance d, it will take 1 hour. So I have taken it as a 1 hour. Okay, while it comes, okay, so while it comes back in 1.5 hours. Okay, while downstream, while it comes back means again it is upstream side. He has given the detail for the upstream side. Upstream side for the same distance d, you will take it simply, so 1.5 hour. That is what they have given, 1.5 hours. Okay, then if the speed of the stream means they have given v, so v is 3 kmph. Okay, so u we don't know, I am writing u minus v, and this will be the u plus v simply because v is given. What is the speed of the boat in the still water? Means they are asking what is v. Okay, simply we can find this. There is no much more logic here. So simple one, because you know the distance. Distance is constant, then the product of these two will be equal. So therefore, I write u minus 3 because distance is equal to speed into time. So what is the distance here? Distance is equal to speed into time. That is u minus 3 into 1.5. Okay, so should be equal to again the same distance, which is equal to u plus 3. Okay, so into 1, u plus 3 into 1. So which is equal to, so 1.5 u minus 4.5 will be equal to u plus 3, u plus 3. Okay, so u plus 3. If you take here, it will become 0.5 u. Okay, so is equal to 7.5. So therefore u is equal to simply 7.5 divided by the 0.5. Okay, so 0.5. So you know that it can be further simplify that, so this is 7.5 divided by 1.5 means 1 by 2. So you 2 will come upside, so therefore 7.5 into 2, so which is equal to simply 15 kmph. So answer is 15 kmph. So the answer is 15 kmph. So that is the solution for this question. So this is the solution for this question. Okay. Next question. So next question. Okay, so this questions comes in the type 3 problems. Okay, so all these video above these numericals they have covered actually. Okay, so type 1 and type 2 problems. Now it is quite this is type 3 problem. It requires some some skills of doing this. This is type 3 problem. Okay, so I will try to understand this one, what they have given here. Okay. See here. Okay, so I have written here. Okay, I call this is a point P. There is a point P. Okay, so there is a point Q also. There is a point, okay, R also. Point R also. Okay, so there is a point P, Q, and R. These are the three towns. What you are mentioning here. These are the three towns. Okay, you can see that this is the town. Okay, so there is a one town here. Okay, so again there is a another town here. Okay, so again there is a another town here. Okay, so these are the three towns on a river. Okay, so on a river which flows uniformly. Okay, so the river is flowing uniformly. Always it moves from upstream side to downstream. Okay, so this I call it as a upstream side, and this I call it as a downstream side. Okay, the direction of the river is also I have given there. Okay, so Q is equidistant from P and Q. From this here, the distance is same. Okay, so if you take P to Q, the distance is same. Q and R distance is same because Q is at the midpoint of P and R. Therefore, of course, I have written that one from, okay, equidistance from P and R. Okay, I row from P to Q. Okay, I'm moving from P to Q. Okay, P to Q, and again I will come back from. Okay, so that is Q to P in a 10 hours. They have given the total journey here. So the total time for this go and coming back is 10 hours they have given. Okay, so 10 hours they have given. See here, what I will do, I will table the things here. Okay, for better understanding, I will table the things here. So I'm using here. Okay. See, this is I'm writing this is okay. So he goes from P to Q, and is again I is okay coming back from Q to P. He will move that same distance. Okay, he will move the. Okay, so P to Q is the upstream side. This is upstream side. Sorry, downstream side. This is downstream side. P to Q is towards the downstream. Okay, so Q to P is towards the upstream. I call this is the upstream. Okay, upstream. And you know that the relative velocity. So downstream is always U plus V. Upstream is always U minus U. You know that one. You know that one. So equidistance I have mentioned, and he has given the total time here. So you can see here the total time. I'm taking the total. I'm writing in between because it includes both this and this. So how much he has given? 10 hour. He has given it as a 10 hour. This is I'm writing 10 hour. It includes both. If I call this is the T1 and T2, then T1 plus T2 will be equal to 10 hour. Therefore, I'm writing in common. Okay, I am writing this one in common. Okay, next. Okay, yes, 10 hour. And I row from P to R means is next in the case 2. This is case 1 he has mentioned. Okay, so in the case 2 is going from P to R. So you can see here P to R. Okay, so from upstream to downstream is moving. Therefore, what will be the speed here? Okay, so when you go from, so if you take this is P to R, is moving towards the downstream. Okay, current is also moving here. So therefore, the relative speed will be simply, okay, so this will be always U plus V. The relative speed will be always U plus V that he has mentioned here. This is U plus. That's why this will be towards the downstream. Therefore, I write it as a U plus V. Okay. Then I can row from P to R in 4 hours. The time taken he has mentioned 4 hours. Okay. 4 hours. And what is the distance? You know that distance from P to Q is okay. I'm showing here because see I'm showing inclined. Okay, just because of the understanding. It's not actually inclined. If I say that, okay, this is how it is moving. So what is the distance here? This is the 2D, and it is moving from U plus V. U plus V. So therefore, so distance I am writing it as a 2D. Distance I am writing it as a 2D, and speed is U plus V. This is the data he has given. What he is asking is asking you, okay, so compare the speed of the boat in the still water to that of a river. So he's asking you what is U divided by, is asking you what is U divided by V. Okay, so I need to solve it. U divided by V. See here. So what I will do is, so I have written here. Okay, I will take that U plus V. Okay, U minus V. So U minus V, I will take it as a 1 by A. It is a common notation I will use always. Okay, this I will take it as a 1 by B. So therefore, I can write it as a upstream side U plus V is equal to, I write it as a downstream side 1 by B. This is upstream side 1 by A. This is also downstream side 1 by B. This is what I am using here. Notation I am using here. Both are same. Nothing but both are same. For easy simplification, I am writing that one. Okay. Easy simplification, I am writing that. Okay. Then, so use this one. If you use this one, okay, so we know that from here, okay, you know that, see here, that is speed is equal to simply distance by time. Okay, when the person goes from P to R, what is the speed? Speed is equal to 1 by B. What is the distance? Distance is equal to 2d. What is the time? Time is equal to 4. Okay, this is 1 by b. So then what will be b? So b is equal to simply 4 by 2d. So which is equal to, okay, 2 by d. Okay, 2 by d. So I have written this one. Take this one. Okay, so b is equal to 2 by d. B is equal to 2 by d. Okay. Next, he has given the another parameter. You can see that. So T1 plus T2, the total time of journey from P to Q and Q to R. So T1 and T2 he has given 10 hours. I'm using this one. Okay, I'm using this one. And what is the time here? If you take time is equal to distance by speed, is it not? Distance divided by speed. Speed is what? 1 by b. 1 by b. And here also the T2 is equal to distance by time, distance by speed. So d will divided by 1 by a. So is equal to 10, is equal to 10. Yes, so this implies that, okay, this implies that, so d into b, because it will comes in the numerator, okay, so plus d into a is equal to 10. Okay, is equal to 10. Okay, so d into b, this is not 6, this is b. Okay, I'm taking a plus b. Okay, so a plus b, if you take d as a common, then it comes to be 10 by d. Okay, so 10 by d. Okay, therefore what is a here? Therefore a is equal to 10 divided by d minus, okay, so minus b. Of course we know that b. So what is b? So 10 minus d divided by, what is b here? So b is 2 by d. This is 2 by d. This is 2 by d. So therefore what you will get, d is the common, you will get 8 by d. You will get a by so you will get 8 by d. You will get 8 by d. Is it not? Yes. So next what I will do is I will take the ratio of these two. Okay. So you know that you have got what is a and what is b. Then you take simply a by b. So what is a? A is equal to 8 by d. You have find out here just now. Just now you have find out a is equal to 8 by d. I have written that one. So a is equal to 8 by d divided by. So what is b? B is equal to 2 by d. 2 by d. Okay. So then what will a by b will become simply, okay, so simply a by b, how much? So dd will get cancelled, it will become 4. Okay, it will become 4. So a by b will become 4. Is it not? So then what is a here? What is a here? Simply if you take what is a, so a is equal to 1 whole divided by u minus v. Okay, I will use the rubber. Okay, so here I'm writing here. Okay, so what is a? So a is equal to 1 by 1 whole divided by u minus. What is b? B is equal to 1 whole divided by u plus v. It comes in the numerator. Okay, so it comes in the numerator. So which is equal to 4 is to 1. So you got this equation now. You got this equation. Now I need to simplify this equation. So I have got that u plus v is equal to 4. Okay, and u minus v is equal to 1. Okay, if you simplify u and u, okay, so you'll get 2u is equal to 5. This means that u is equal to 2.5. If u is 2.5, then what is v? So v will become 1.5. Okay, so v will become 1.5 because 2.5 plus 1.5 is equal to 4. So 2.5 plus 1.5 will become 4. What they have asked in the problem, they have asked to find out u by v. They have asked in the problem to find out, okay, so to find out u by v. So therefore writing here, so u by v will be equal to, so what is u we have find out? So 2.5. Okay, so divided by 1.5. So 5 3s are 5 5s are. So you'll get 5 by 3. Okay, so you'll get 5 by 3. Therefore the ratio is simply 5 by 3. So the ratio of u and v is simply 5 by 3. So this is the answer for this question. These are the type 3 problems. Okay, so you need to practice this one in order to boost your speed in the examination hall. Okay, you have to do very fast. Okay, so therefore the ratio is 5:3. Therefore the ratio is 5. So this is the So this is the solution for this problem. This is the solution for this problem. Okay. Next question. So next question, this is okay friends, that's it for the today video. Stay tuned with my channel for more updates. Thank you.